Hi folks, this is Kareem Raouf from IT Visualizer channel. We will continue our lab, the matrix labs, the video number 128. We have been discussing in the previous video the following. We have begun discussing the topic of how to use Microsoft Sysinternals suite to troubleshoot Windows. This suite contains a lot of useful utilities that you can use to troubleshoot different problems concerning Windows. Okay, we have seen that one of these tools are PSExec, which we have already discussed in a couple of videos before. Today we will discuss the different utilities of this suite. We have seen hands-on exercises to explain these tools. We have seen before the hands-on exercises, we have seen uh, a little bit of an explanation of each tool and what does it do exactly. So let's continue with our hands-on exercises to explore these tools. We have stopped the last time at a tool called sdelete. This securely deletes sensitive files and can free some space. Create a test file with dummy sensitive information. Let's try to see if we can create a file and try to delete it using this utility. First of all, we will go cmd and then try to open it with administrative rights. This to securely delete it with three passes: sdelete minus cc to clean free space in your system. What to observe the secure deletion process and confirmation. So this to clean free space, I need to know what are these two exactly. If we go to Microsoft documentation, delete, let's see what this utility will do. Here you go, this is sysinternals, and then let's see what this command do exactly. So uh, okay, let's see what this do exactly. So it is a command utility that makes a number of options in any given use. It allows you to delete one or more files or directories or cleansize the free space on a logical disk. sdelete accepts wildcards. So let's see what this means. Minus C, clean free space. Uh, so let me see here. This okay, so this is to clean free space on your disk drive. So this will free some space. This is what he means. Minus cc. What about minus p? Minus p here means that specific number of overwrites passes. Default is 1. I don't actually understand what this means. Let's see here this. How sdelete works. Securely deleting a file that has no special attributes is relatively straightforward. The secure delete program simply overwrites the file with the secure delete pattern. What is more tricky is securely deleting Windows NT, to be compressed, encrypted, and spare files, and securely cleanizing disk free space. Compressed, encrypted, and spares are managed by NTFS and so on. So if a program, so I think it's related to deleting encrypted files. So let's see here the conversation. Encrypted. Uh, okay, to handle these types of files, sdelete relies on the defragmentation API. Using the defragmentation API, sdelete can determine precisely which clusters on a disk are occupied by data belonging to compressed, sparse, and encrypted files. Once sdelete knows which cluster contain the files data, it can open the disk for raw access and override these clusters. Cleaning free space presents another challenge, since FAT and NTFS provide no means for an application to directly address the free space. sdelete has one of two options. The first it of that it can, like it does for compressed sparse and encrypted files, open the disk for raw access and override the free space. This approach suffers from a big problem. Even sdelete were coded to be fully capable of calculating the free space. So I think here this is, I think, related to related to deleting encrypted files. So as we can see here, securely delete sensitive files and clean free space. So here we have these two. So this will delete it with 3 passes. I think this is maybe a deep deleting or deep cleaning of a file or deleting of a file. Okay, so this I think I will not be able to do that, but let's go further and see the other things. Streams, discover alternative data streams, create a test file. Yeah, okay, this is text file. Add an alternative stream, echo hidden content, file text file hidden, verify stream text file to try to view how alternative streams can be hide in plain. So I think here this uh, it creates a hidden content maybe. This is, I think this is very very strange. Let's try to see what this do exactly. We will do like this and we will make like that and make, let me try to uh, uh, put this file on my desktop. So let's do like this, or C, or put it in the C partition. So here we will put main content like this, and then we will put hidden content. Okay, and I think this is something like revealing hidden context. Okay, or hidden context. Let's see this one. Okay, so we have this like hidden, so we have main content and we have hidden contact. Okay, so let me try. Oh, sorry, actually this is not correct. Let's go to uh, C like this and tell him hidden content. Let me try to see if I cannot see this thing. Let's go first and open the file. So here we go, this is, double click, and this is C, and then we have like test file. Okay, so we have main content only. Okay, the hidden content is not displayed. So I think this thing or this utility can let us see the hidden content. Let's try streams, text file to text, verify. So try to view with more. Uh, I don't let me see what this means. Okay, streams. Let's see if we copy like that, and then we have it like this. Okay, and then we put like this. C. Okay, C, and then like this. Let's see what this will do. So let's agree. Uh, so hidden SD data. So what this will do exactly? Okay, this, we have a hidden data. Okay, how we can see this? So this is hidden. Okay, try to view with more hidden. What to observe? How alternative uh, data streams can hide information in plain text site. Let's try to see if we can how this will be done actually. More slash text file hidden. So we need to have a streams. Let me see what streams do exactly. If we go there and ask it to streams, okay, here you go, there is streams. uh, Microsoft says internal streams. Okay, here you go, that's it. Let's see what this utility do exactly. uh, mm, minus S and minus D. recursive subdirectories minus D the ability to create alternative data streams of information. By default, all data is stored in the file mains unnamed data stream, but using the syntax file stream, you're able to read and write to alternative. Not all applications are written to access, but you can demonstrate simply. I don't think I can understand these two. Okay, so this create a test file, add an alternative string, echo hidden content, and this file will be hidden streams, so and so. There will be a hidden things. Try to view with more uh, what can I do with this? Let's try to see if what this will do exactly. If we'll go there and tell him see, let's see how this will do. If I can see that. Okay, so here I can get the content. So simply, very simple. I think this is like putting put hidden data in a file, which actually is something very strange. Let me try to have a little bit of an explanation of delete and streams, because actually I don't know what these two do exactly. Let's try to ask to Grok, for example, to explain these tools. Okay, let's try to do that and go a new one. Explain what delete and streams Microsoft Sysinternals tools do in simple terms. Okay, let's see how this will do, or how he can explain these two utilities, because actually I cannot understand what they do exactly. Okay, so let's do like this and try to see what will be the answer. Okay, so I think here is I mean by secure delete to prevent data from recovery. So I can delete a file and securely delete it, and no recovery programs can retrieve this data. So I think this is like shredding files or something like secure delete. Let's try to see what the other utility streams do exactly. Okay, so here you go. sdelete is a tool that helps you securely delete files and clean free space on your disk. When you delete a file the normal way, like with the recycle bin, the data isn't really gone, it's just marked as free space. It can still be recovered with special programs. Not like this is not like with I think this is shift delete, not like with the recycle bin. So here I think shift delete, and then you can get the recovered or get the files by special programs, or deleted files by special programs. sdelete makes sure that the data is completely erased by overriding it with random patterns on 0. This means no one can recover your deleted files. So this is a good thing. Deletes files that they cannot be recovered. Clean up the free space in your drive to erase traces of all deleted files. Uh, so this to claim free space. Okay, just mark it as free space that can still be recovered with so clean up free space in your disk to erase traces of all deleted files. So why to use it? Great for protecting system information, like before selling a computer or hard drive or meeting data privacy rules. So it's like wiping data programs, okay, or secure deletion. As for streams, is a tool that lets you find and manage alternative data streams in files on NTFS file system, okay, the file system used by most Windows drivers. Alternative data streams are like hidden compartments in a file where extra data like metadata or even malicious code can be stored beyond the file's main content. So this is like adding hidden extra information that is not visible uh, in the file. So what does it do? Shows you if a file has alternative data streams attached, lets you delete those streams if needed. Why to use it? Useful for security check, like finding malware hidden in streams. Okay, so that's good. Help developers or users who work with streams on purpose. Like sdelete is a command line utility. You point it at a file or folder and lets any alternative streams or lets you remove them. So sdelete security wipes files and frees disk space so nothing can be recovered. Streams finds and handles hidden data streams in a file for security or management. So that's it. Now we know that we have a couple of things. So here I have already added a hidden text in my file. So how can I delete it? If I go to the streams, here we have -s delete streams. So here we can go like that and tell him s streams, tell him -d, I think here, and uh, so here I think this -d will delete the stream. Let me see if this will do. Okay, so now it is deleted. If I try to have more and hidden, okay, so we cannot delete the hidden data. So now he has deleted the file. There is no hidden data. So let me try to see. Okay, so now the file itself is deleted or the content is deleted. Let's try to see now if the file still exists. I think there is, or it's still there. Okay, so yes, it's there, but it has already deleted the content. Okay, the hidden content. So this is good. We have two utilities that actually I don't know that they were existing before. So this is a good thing. Now we have exercise 9, auto runs, clean startup files or startup items to improve boot file, launch auto runs and go to the login tab. Let's try to see, because actually this is very interesting. I will go to the D and I have my sysinternal suits. This is a graphical interface utility. We have auto run. Here you go, that's it. Auto login or auto run. This is auto run, 64-bit. Let's try to run it. Now you can see a lot of things actually here. Let's see the exercise saying that launch auto runs and go to login tab. Let's go to the login. I think this is the things that will uh, uh, pop up or run automatically when I log into the login with my Windows user account on my laptop. So I think this is most of them. Free download manager. I have Google, I have Edge, I have Adobe Reader, I have uh, OpenShell. There is a Smart Audio. There PDF24. All of these are actually the things that run when I log in. So all of these are VMware. I have VMware. So there is a lot of things actually here running when I auto login, or when I log in, sorry. Let's see here. Identify non-Microsoft entries by clicking options and hide Microsoft entry. So identify non-Microsoft entries by clicking options. Where is options? Okay, and then hide Microsoft entries. So now these are all the programs, non-Microsoft programs that auto run when I log in with my username. Okay, my Windows username. So that's good. Here we can see a lot, or this is better, and we have a lot of things here related to auto runs. Okay, so I think we need to have something like exercises concerning this utility. Schedule task, we see this will auto run, so this tasks I think it will run automatically when I log in. Maybe I think this all of them are I think yes, most of them when I log in. If I try to see any one of these this schedule task, I think this when I log in. Let me try to see the backup. For example, this task, I think this is when when I log in. Let's see the backup event. This is I think a utility, or this is a job that I have done to back up my event logs. Let's see the triggers or the action. Trigger daily conditions. Okay, I think generally when let's see the actions. Start a program. I think let's edit this one. So start a program, and I think this is, let me see here what this will do. So I think when I log in, this when I log in. Okay, yes, on a schedule task, not at login, but this is scheduled to run, not during login. So I think this is not related to auto login, but it gets the tasks that uh, run or auto run. Okay, so this task automatically run. Maybe this is what he means here. Anyway, so let's try to see the other uh, exercises. So now we have this. Search any unfamiliar entries using the search online. So I can do that. Let's we go to the login and right click, for example. Here we can search online. Let's see this. So this will get you the name of the file, so you can make sure that it is already a valid entry or a program that you know. It's not a malicious program. Disable, do not delete suspicious or unnecessary startup files, what to observe. So I think from here we can disable. So for example, here we can tell him to uh, properties. Maybe I think I have already disabled this. So let me see here. I think I have already disabled this one. So this, let me see if it can be disabled. Okay, let me try to see the properties, how we can disable that, if there is any way to disable this properties maybe. So here is saying that you can go and disable, do not delete a special file or unnecessary startup files. How to do that? These are registry keys. Okay, so this is not something we can delete. You will not delete. There is something to and then we have something like the process explorer. You can get the things related to this program through the process explorer. Anyway, so let's continue with the other programs. We have handle, identify open file handles causing in-use errors. So this is a program that will tell you if a file is still opened even though it appears to be closed. Sometimes we have this situation. For example, you want to open a file and it's telling you that someone is already opening the file elsewhere. Okay, so handle to see what process has it open. So for example, try to rename all data file that the Windows say it is in use. This is very, very typical. For example, you are working on a file and someone is trying to rename this file or delete this file. So it will give you that it is in use. So we can do that and see who is using the file currently. Okay, so this is a good thing. List DLL, the other program, verify loaded modules in a process. Run list DLLs Explorer to see all DLLs loaded by Explorer. The Windows Explorer, I think he's talking about that. What are the files loaded by Windows Explorer? list DLL minus R to see which DLLs has been reallocated in memory. List DLLs minus V Chrome to see version information of Chrome's DLL. What to observe? I think all these are related to DLL. What are DLL files used by different programs? For example, maybe Chrome, maybe Explorer. Proc dump, this is to create a dump of a certain program. We can see this can be done using the Process Explorer or proc dump. You can use this to create a full dump of Notepad. This command to capture a dump when CPU exceeds 90% for 5 seconds for the Chrome. Okay. As for this one, to capture a web server process when it encounters an out-of-memory exception. Okay, so that's good. All of these are very, very good. As for Process Explorer, this is one of the famous utilities of Windows Microsoft Sysinternals suite. Let's try to see the Process Explorer. I think here you go. This is the one, and try to open it. Okay, let's go. I think now we have this one. So let's see the explanation here. Launch Process Explorer and enable Show Process Tree. Where is Show Process Tree? View, Show Process Tree. So every program, the sub programs run from it will be like a tree. So again, what we need to do after that, we will go and see sort by CPU, memory, or I/O to identify resource intensive programs. So just we can see what is taking so much process from our CPU. So let me see. For example, here we have okay, so we have 26% or 24% cam recorder. This is the one using much process. I think this is for the RAM, maybe system commit, physical memory 6.2. We have I/O, read and write, the program session. But here I need to let me see if we can. This is 2 by CPU. I think here we can add select columns. We can add where we can add so here process disk, read and write, process I/O, process memory. So here we can add all of these private bytes and working sets. So this is it for the memory. We can see that the most using memory is the Firefox and a cam recorder. This is for private bytes and working set. All of these are memory for this one. As for the CPU, who is using most CPU? If we go further, CPU, we can see that the most is cam recorder. It's taking about 12% or 15%. Good, we can see a lot of things here concerning the resource usage. We can see here that he's telling us that the most using the CPU is here we have the total, and under it we have the first one, I think, or the most intensive use, which is cam recorder. If we go there, we have, for example, for the memory 6.1. This is the used memory. For the I/O, the most one using or having read and write to the hard disk is cam recorder, actually, because the one I'm using now. So that's good. We have GPU, or for the graphic cards, we have program called DWM, we have 7.50 used and 6.68 or 86 used by this program. And we have, so I think all of this is very, very good. If you go and try to see another thing, right click on any process, select properties to view detailed information, check verify signatures under options and look for unsigned process. Okay, let's try to see, for example, any one of these. Let's go to Firefox maybe, and let's go there and try to get the Firefox. Where is the Firefox? Let's search for Firefox. There you go, and then we can right click and properties. Now we can see all of the things related to Firefox. Okay, data disk or the location and a lot of things actually related to this software, the handles, the DLL, the threads. So a lot of things actually you can get from this program. Process monitor, we have seen this before, that can take or can capture the resource usage for a certain program during, for example, a couple of minutes or a couple of seconds, okay, or as you wish. We have PSExec, we have seen this utility before. It's very, very good. We have VMMap, analyze memory usage patterns, launch a memory intensive application, a browser with multiple tabs, run VMMap and select the process, observe the memory breakdown by private, mapped, and shareable, take a snapshot, perform more action in the application, then take another snapshot, compare the two snapshots to see memory changes. So let's see first VMMap, this program. We have VMMap. Here you go, that's it. And we have to run it. So let's try to see. So here you go, view a running process. Select, let's see the Firefox, for example. Okay, as you can see here, this is the Firefox, and actually what it is using currently, we can see the memory. So it's take about half giga maybe, private and working, a couple of useful data actually, and this I didn't use it actually before, but you can capture data. For example, here select the process and then how we can capture data. So here trace snapshot interval. So I think this is here to take a snapshot anyway, so I think I didn't use this program before, and I think maybe you can use it later. We have TCP view. This is also one of the things to see the connections to your PC. What are the programs connecting on your PC? Something very, very useful. Let me show you guys what this utility do. If I open TCP IP, let's go to TCP. Here it's TCP view, and tell him like this and run as administrator. We will see that here are all of the programs. Let's go to the state. So let's go, what are the established connections? If we go further, we have, these are all the programs having established a connection outside. So for example, here we have Age, it already established a connection with this website or this external IP, okay, through port 443, okay, as we can see here. And you have the Firefox, and actually very, very useful. You can see here that the protocol used, the established connection, the listening ports, what are the ports that are listening or waiting for us to connect on. Very, very useful. As you can see here, a lot of things we can get from this program. Very, very useful. When you are tracing a hacking process, you need to know what are the connections established on your server or the hacked server. So this is very, very good. Let's continue with the other utilities. PS ping. This is also another utility you can use to or this is better than the ping, the normal ping. This is much much accurate. You can control how much packets you need to ping to test latency over 100 pings. Here, this is other thing to test the bandwidth to a server. We will see that later. We'll talk about this utility later. You can make a testing or environment, or you can test the latency in your network through psping. Okay, you make a server, a psping server, and you ping to it, and through this ping you will see the latency. Okay, psping minus l so and so to see if jumbo frames are supported. So you can ping to a website by numbers, and also you can ping with the bytes, so you can specify the size of the byte, the size of the packet that you will ping with, or you can tell him the number of packets, and it has a default size of 32 bytes. Okay, so this is simple. We can just get psping like this one and try to uh, take it much simpler. Let's try to do that. Here is psping, and we will copy, and let's go to cmd again, and let's go like this and try to run. Okay, so we can do like this and try to make it like 10 only, not we don't need all of this one. So let's see how this will work. So this is 10 uh, 10 packets. The default size is 32. You can change the data size, or the data packet size, through this minus L minus H. I don't know minus H what it means actually. I think minus H will this is, I think, a parameter we need to know, and this is the IP address. Let's see also psping here. We have here psping, and actually we will see some scenarios concerning all of these utilities, but let's see what minus uh, let's see here, minus h print histogram. We will see what is an histogram later. We will have a separate video for psping, by the way, but here we can see that we can let me show you. For example, I will take this one and I will tell him I need a packet, for example, not 32 byte, but let's see, for example, uh, maybe 50. Okay, let's try to copy this one and try to change the psping like this one. Okay, and try to tell him not to do that, and then minus h, let's try to make it like 50. Okay, and then minus n, and then let's make it 10, and let's see how this will do. We will make it 10 uh, 10 packets. Each packet is 50 50 bytes, okay, instead of 32. So this is useful if you need to test the network traffic. So if large packets are sent fast, then your network is okay. Okay, just to make sure that you have your network traffic, or you have your network in not exhausted. For example, let's see minus L 50 minus N Microsoft.com. Let's see this one. So as we can see, this is 50 bytes, and now we have it's pinging, and this is very simple and useful utility, much more accurate than the ping, the normal ping. AD Explorer, navigate and search Active Directory. Okay, you can go through it. Something like Active Directory console. Active Directory uses a computer's console. Here, you can use it to connect your domain browser through the organizational unit, search the feature use the search feature to find specific user computer. Create a snapshot of the Active Directory for offline browsing. You can take it, I think, like a copy of what the Active Directory contains. Create a snapshot for offline browsing. This is very, very good. Share Enum. Audit network shares for security issues. Run share EMU on your local network. Identify shares that allow everyone full control. So this is good. How we can do this is also to get the shares on my computer. Okay, so if we open this utility, it is a graphical, or let me see if we have a share. Here you go. I think this is a graphical one. If you try to run it, let's see this. So okay, this doesn't seem to be a graphical one. I think it's not a graphical one. Let's try to tell him, let's see, copy, and try to see if this will do something. Nothing. Let's try to see what is share share emu. Okay, let's see this share emu and try to see if we can work with it. Here you go. This is the one. So why it doesn't work? So again, if I try to run it like this, see this one. So it is not working for a certain reason. Let me try to see why. Okay, where is share? It's not working for a certain thing. Maybe there is a problem. Anyway, so this is a utility. As you can see here, you can use no domains or workgroups are found on your network. Okay, so this is okay. This is for the domain or network or work group shares. Okay, so this is good. Very, very good. Okay, you can quit. So this is good. Now we have share enumeration, and then security utilities, auto login, configure automatic login for environments. This is when you need to make auto login for lab environments. Run auto login and enter credentials for an account. Reboot to verified automatic login. So this will create an auto login user. Okay, so you can just give him your account and your password, and he will auto login on with your user on a certain machine. Okay, so then you can disable it, auto login, and click disable to turn off automatic login. So this is good. Login sessions. This is good thing. Identify active user sessions. Login sessions. Let me see what are these things that are popping up. Maybe there is something and I cannot see. Okay, let's share enumeration. We will quit. Okay, and then quit. So let's see the login session. We will see login session, list all login sessions and associated processes. So I think this is maybe something like TCP, or this is related to users. Let me see if we can do something like that. -p. Let's see. So I think this is maybe something like uh, like uh, TCP view. Okay, let me see this. So let's see. Here we have. If you go further down, let me see here. We have login session. So we have all of these programs. Logged in, login session 1. This is the sessions. Okay, so we can see the login time. I think this is related to users or programs. So we can see a lot of things. There are services, or for example, like Net Authority, local user login. So that's good. We can see a lot of things. If there is any remote sessions, I think this is also will be listed here. Okay, so we can see, here you go, this is are all the sessions. I think this is maybe like TCP IP view. Look for unexpected session processes running under other users. What to observe: all the active sessions on your system may reveal unauthorized access. Okay. Sysmon, set up advanced system monitoring. Sysmon.i to install with default configuration. Perform various activities like executing programs and creating files. Open event viewer and navigate to application and services logs. Microsoft Windows Sysmon. Review the detailed event logged by Sysmon. What to observe: extensive monitoring capabilities beyond standard Windows logging. So uh, this is a login utility, which is strange. I didn't use it before. Okay, we have the other utility, SigCheck, verify digital signature of executables to see if the programs are signed. This is good to know if it's a verified file or a trusted file. So for example, this to check digital signature and virus total results, -u program to show only unassigned files. Let's see if we have any unassigned files in my program files. Uh, if you need to view the file hash for comparison, okay, this is a good thing actually. If you download a file and you need to make sure, and you have the hash from the website, and you need to confirm that the downloaded file hash is like what is stated in the website of the company, this is also good thing. So let's see if this also can help us to the signature. Let's go there and try to see if we go make like CLS. Let's go there and tell him CLS and see this one. Let's see this one. So here I think there is a problem. We need to have a parameter. So we need to check -u. Where is -u? -u means here dump contents of specified -u. If total virus check is enabled, show files that are unknown by virus total or have zero detection. Otherwise, show only unassigned files. So this is why it didn't work. For certain reason, why it didn't work. Maybe because there is space between the between programs and files. Let me try to see. Uh, let me do it in a certain way. Okay, let's not have the C, but let's have the D, for example. Let me go and try to make it on the D. So where we can I don't have any programs, so we can go there and tell him, for example, like this. But I think we need to have quota or something like this one. But I think this will take a lot of time. We can go to the D, for example, to take a small file, maybe or a small folder. Maybe let me get it like Sysinternals to see if it is signed by Microsoft. So we can copy that to verify that these are signed. Okay, let's do like this. Okay, let's see if this will work. -u. So I think this is working. So strangely it's saying it is unassigned. Let's go further and see. So here is getting us sorry guys, here we get the all of the files, and he's saying that okay, not all of the files, the HCM or the help files are not assigned or not signed. Okay, so this is good. The programs itself are signed, but the help file for the programs are not signed. So this is good thing. We can see here that and a couple of programs, a certificate was explicitly revoked by its issuer. So there is a problem with some files like this one. We have HCM, we have EOLA. Most of them are text files. Okay, unassigned uh, text files or help files. .hcm, we have text files, SZF, this is the one I have created. It's not signed. Let's continue. TCP view, now we have, let me continue with the things here. So all of these are good, okay? We can know if anything is verified or not by using this utility. Okay, and if we need to have a certain file to see the hash of a certain file, this is also is good. Let me try to see a hash for example, a hash of a certain program like this program, autologin, for example. Let's get, let me wait for a moment. So let's see if this file, we can see the hash of this file. Okay, so we can do like this and tell him paste. Let's see. So here is the hash. So you can go to Microsoft website and see if the hash of this file on their website is the hash that you have already downloaded or the hash for the currently used file. Okay, so you see the hash. Let's see, for example, auto login. Let's see auto login, auto login, Sysinternals. Yes, that's it. Let's see the hash of it. So let's see if we can see the hash. Where we can see the hash, auto login, sysinternals, how we can know the hash of this file. Let's see auto login 64 and hash, hash, hash file. Okay, let's see if this, how we can hash file. Where is the hash? Okay, I think we cannot get the hash from here. Collects the hash. Okay, I need the hash for the file anyway, so we cannot see anything from here. Where is the hash file? It is introduced. So we can see from here, this is the hash. We can compare it if we have the hash provided by Microsoft. Okay, so anyway, this is signed, so we are good to go. And this is the hash. Okay, so very good. If we continue with the other utilities, clock res, check system timer resolution, run clock res to see the current system timer interval, launch a multimedia application or game, run clock res again to see if the timer resolution change. How applications can change system-wide timer resolution affecting power consumption. Uh, how this is, I don't know how this works. Clock res, let's see what is clock res. We have something like this, clock. This is clock res, but I think this is okay, I think this is a graphical interface utility. Let's see. So no, this is not. How we can use it? Run clock res to see the current system timer interval, launch a multimedia application or game. Run clock res again to see if the timer resolution changes. What to observe? How applications can change system-wide timer resolution affecting power consumption. Let's again see what is clock res here. Clock res. Okay, here you go. This is it from Microsoft. And ever wondered what the resolution of the system clock was, or perhaps the maximum time resolution your application could obtain? The answer lies in a simple function named get. And so clock res applet performs the function and show the result. get system time adjustment. Uh, Ever wonder what the resolution of the system clock was, or perhaps the maximum uh, time resolution for your application? I don't actually think I understand. So let's try to ask uh, Grok to explain. Explain this utility in simple terms. Give an example. Let's try to see this one, okay? So let's see the answer here. Okay, let's try to see what is this program exactly do, or what does the program exactly. Small utility that tells you how precisely your Windows computer can measure time. Think like a way to check how finely tuned your computer's internal clock is. The clock is what Microsoft or Windows use to keep track of time and schedule tasks like running programs or updating the screen. What does it do? In simple terms, clock res shows how the small chunk of time your computer can reliably measure or use. This is called system clock resolution. For example, if the resolution is 15 milliseconds, your computer can only tick or update every 15 milliseconds. It cannot notice or act anything faster than that. Okay, so if there is a program that runs uh, less than 15 milliseconds, it will not notice it. These tools give you three precise piece of information: maximum timer interval, the biggest time chunk your system can handle; minimum interval time, the smallest time chunk your system can handle; current timer interval, the time chunk your current system is using right now. Why it is useful? If you are a developer making a game or app that needs exact time, like playing a sound every 5 milliseconds, this tool tells you if your computer can keep up. Okay, that's a good example. If something in your computer feels slow or off, clock res can help you figure out if the clock's time is a part of the problem. Okay, uh, it's handy for power users who want to tweak their system for better performance. An example, let's see this one. Imagine you run clock res on your computer and it shows maximum interval time 15.625 milliseconds, minimum timer interval 0.5 milliseconds, current timer interval 15.625 milliseconds. So what this means, your computer clock currently set to update every 15 milliseconds. Okay, 1 over 64 of a second. It could go as fast as 0.5 milliseconds if needed, but right now it is using the bigger, slower setting. Now let's say that you're playing a game that needs to update every 10 milliseconds. Since your clock is ticking at 15, the game might feel choppy or delayed because the computer can't keep up the 10 milliseconds timing. It's stuck waiting for the next tick at 15 milliseconds. So, okay, that seems good. How does it work? Clock res check your system by using a Windows function called get system time adjustment. This function grabs the details about your clock's timing and clock res shows it to you in a simple command line window. Don't need to be a tech expert to use it, just run it and it tells you the numbers. In short, it's like a magnifying glass for your computer clock. It shows how small or big the time steps are that your system uses, which can help you understand why some tasks work smoothly or why they don't. It's a simple but powerful tool for anyone curious about how their computer handles time. Uh, okay, how can I run it? Let's see if we can. Where is the parameters? Clock, res. Let's see if we can run it. Here you go. This is clock res. Where is the utility? So let's ask Grok. Give me. Where is Grok? We have Grok now. Where is the last one? Okay, here you go. This is. Here you go. This is the one. Okay, here you go. This is it. Give me the command to run on my laptop. Let's see if this will do. So let's see. So just I need to run it from the command prompt and that's it. Okay, let's try to learn the clock res and let's see this. So here you go, very simple. We have 15 milliseconds, 0.5, it is 1 millisecond. Okay, that's good. We have maximum 15 and 1. Okay, that's good. So I actually very curious if we can use or we can use such utility in certain situations. Can you create a real world scenario where I can use this utility? So let's see how this let's see what he have. Okay, let's see the example here. Saying that you are a hobbyist musician using a digital audio workstation like Reaper or Ableton Live on your Windows laptop to record guitar tracks. Lately, you have noticed that when you play along with a metronome or backing track in the app, the time feels off. There is a tiny delay or lag between your guitar strums and the sound coming through your headphones. It's driving you crazy because it throws off your rhyme. Suspect it might be related to how your laptop handles timing. Your DAW needs precise timing to sync your live playing with the recorded tracks. If your laptop's system clock is too coarse, like 15 milliseconds, instead of rather of something finer like 1 millisecond, it could cause small delays or jitter in audio processing, making everything feels out of sync. So we will use this utility and see the output. How we can do this? Okay, with laptop can process taking action. You search and learn that some Windows applications like video players or power saving features can force system clock to be a slower resolution to save energy. To tweak your system, closing unnecessary background apps, switching your power plan to high performance in Windows, so and so, restart your DAW. Good thing. Then we see the current interval 1 millisecond, okay, which is better for audio work. Okay, this seems to be a good thing. So, okay, I think this example is fair enough. Then we can go to the next utility, called core info. Understanding your processor's features, core info minus v to display verbose processor information. Note which processor features are available, marked with X. Check for virtualization support, look for VMX or SMB flags, but to observe the detailed process capabilities, including those needed for virtualization. If we tell him core info, let me see what this also will get us. Core info, I think maybe we will stop at this utility, but let's see what is the info gathered. So let's see. So here there is uh, something. Note, core info must be executed on a system without a hypervisor running for accurate results. Okay, we don't have any hypervisor. This is the processor, the family, microcode, the error loading, the driver has been blocked from loading. Okay, so this gives us the model and some info. Okay, this seems to be good. We will stop at RAM map, analyze physical memory usage. I think I will stop at this utility and we continue in the upcoming video with God will. Hope this video is informative to you all and thank you all for viewing. Thank you so much.